Today I want to do matrices. So a matrix is a rectangular pattern of elements arranged in rows and columns. And it inenge iri rectangular pattern inenge iri arranged in rows and columns. So that's our matrix definition. This is the matrix definition. So now let's move on to matrix of order. Matrix of order, it's P by Q. So means it is P rows and Q is columns. So to is P ma rows, then Q ma columns. So order of matrix not row by column. So row by column. And it those are not areas. So for example, number 1 we have this one, A, B, C, D. Number 2 we have this one, A, B, C. Number 3, A, B. Number 4, A, B, C, D, E, F. What is the order of matrix of those matrices? So first thing, number 1, what is the order of matrix of this one? So order of matrix, row is horizontal line, then column is vertical line. So row to not 1, 2. So it's 2 by column 1, 2, 2. So order of matrix of this matrix is 2 by 2. So pana row is 1 by column 1, 2, 3, 3. And then panapa it's 1, 2, 2 by 1. Panapa 1, 2 by 1, 2, 3, 3. So do my rows of columns and do order of matrix. So alright, addition and subtraction. Addition and subtraction of matrices and of matrices. So addition or subtraction of matrices, it is sometimes possible to add and subtract matrices. The process is carried out by combining all corresponding elements. So for example, we have 1 and -1 na 2 na 3 and plus number 1 this one, 3 na 4 na 2 na ukatiti nani na 1 na 6. So zinenge zichitika pana ma corresponding, combine ma corresponding or corresponding elements. So pana tiri kuti apa plus apa, 1 plus 3, then apa plus apa, 2 plus 1, apa plus apa, -1 plus 4, apa plus apa, 3 plus 6. And so panapa we get apa 204, -1 plus 4 203, 2 plus 1 203, apa 3 plus 6 9. So do addition and subtraction. So toda kuita isusu minus anditi katite ina minus pana. Sapana patakuya takuti 1 minus 3, 2 minus 1 minus 1 minus 4, 3 minus 6, handiti. So panapa takuti source apa negative 2 apa negative 5 apa 1 apa negative 3 noveres yapere energy subtraction. The example 2 yacho. So now we are going to do scalar multiple of a matrices. Alright, takuita anonzi scalar matrices, and kana chiti scalar matrices e.g. K, A, B, C, D, where K is a scalar multiple of the matrices. This one. Do yache. Then chiti papo kana chiti so scalar matrices and so scalar matrices multiply each every term, and this means we will multiply each and every element in the matrix. Multiplier each and every element in the matrices. So panapa K times A, tiona KA, K times B, KB, K times C, KC, then KD. So for example, tina 1 over 2, 6, 8, negative 2, none, na 4. And so half is a scalar matrices, and certain takuti so half times 6 tiwana 3, half times 8 tiwana 4, half times negative 2 tiwana negative 1, half times 4 tiwana 2. So ndo inonzi scalar matrices. Right, takwenda yatinoti so multiplication of 2 by 2 matrices. So multiplication of 2 by 2 matrix, we use row by column anditika. So for example, tina A, B, C, D ari kufana ku multiply na E, F, G, H. And so first step unoya panapo vhura bracket rako woisa 2 ma brackets ari ku multiply ari ku plus apana anditika. Then woya pana woya pana anditika. So panapa tikuti A each cha multiply na each, then each will multiply na each. Sangatiti A times E plus B times G, B times G anditi. So A tapedza row by column, then takwenda side ndo E. Satakuti row by this column. A times F, A times F, then B times H, B times H. Saka panapa tabu sapera kasupa msores. Then takuya takuti so this one times this one, row by column, anditi. F, H, anditi. So takuti C times E, C times E, then D times G, then takuti C times F, C times F, then plus D times H, T times H, and 1. So kwakuya panapo wakuti AE plus BG, AF plus BH, 2 times C times ECE plus DG, apa CF plus DH. No very parent. So this is, so let us do using numbers. right, toda kuita isusu this multiplication handiti tatinoya tovhura chi mabrackets edu apa plus handiti toya pana plus toya pana plus toya pana plus handiti. So 2 times 1 it's row by column. 2 times 1 2 times 1 then plus 3 times 0 3 times 0 handiti. Then 2 times 0 row by column. 2 times 0 plus 3 times 1 ndizvoka. So takuya pana zvapera kaizvo takuti row by column first. 1 times 1 plus 4 times 0 then zvapera kai row by column 1 times 0 4 times 1. If you want to see kuti this is correct unoona 1 1 0 0 0 0 1 1 should be same handika. So panapa takuya takuti susu pana 2 times 1 is 2 apa 0 apa 1 apa 4 apa 0 apa 0 apa 3 apa 1 apa 4. So this is identity matrix. All matrix multiplied by identity inodzoka yakadaro handiti. Yese matrix multiply neidentity matrix inodzoka yakadaro. So panapa takuya takuti 2 plus 0 is 2 apa 1 plus 4 apa 0 1 plus 0 1 apa 0 plus 3 is 3 0 plus 4 4. Mukona kuti ishi yafanana this one. So this is multiplication of matrices. Determinant of 2 by 2 matrices in general we have A, B, C, D. So we want to find a determinant of 2 by 2 matrix. So first thing, determinant of 2 by 2 matrix, not A times D. First step, A times D. A times D, then minus. We use minus if you want to find it. When you find the determinant, you use minus, and it need to sign negative minus. So then when I talk to C times B, C times B. So our answer is A D minus C B. And so this is our determinant. For example, 2 3 1 4 and it determinant yedu ndiana ijia. Determinant yedu ndiana 2 by 1 2 by 4 2 times 4 minus 1 times 3 1 times 3 tuona isusu apa 8 up minus 3 tuona 5. Okay. So this is our answer. Determinant determinant. Takuya inverse of 2 by 2 matrices anditika. So it is denoted by A to the power -1 or B to the power or P to the power chingoenda n later to the power -1. So zvinchireva kuti inverse anditi. So in general, if you want, when you find the inverse, first step you find the determinant, and the last step and third step or 31st step and it unotsvaga inverse, unotsvaga determinant. Find the determinant first, then second find the inverse. And so for example, we have 2 3 -1 and 6. So first we want to find its P of 1 0 tsvaga P inverse and it. So gatangita tsvaga determinant first. Determinant apa tati 2 times 6 minus 3 times -1. So pana tuona 12 minus 3. So tuona 15. So inverse yedu takuti p negative 1 is equal to tinenge takuti 1 over 15 1 over determinant anditika toya pana takuti isusu 2 idzi numbers dzochinjana maposition changing positions and saka 6 akuya panapa 2 yapana and 6 aenda ku 2 enda then idzochinjana changing masign so panapa yanga iri positive so yana negative 3 panapa yanga iri negative 1 saka yana positive 1 so this is inverse. Alright, singular matrix. So singular matrix, a singular matrix is got determinant 0. Is got determinant G. Determinant is got 0. Tunzana. So tine question yedu iyo. Right, tine question yedu iyo panapa irikuti you're given that X matrix, this matrix is a singular matrix. So singular matrix is determinant 0. Find X. So first thing, let's find the determinant of this matrix. Determinant of this matrix is X times 3 minus 2 times 1 2 times 100. So we get 3x minus 2. Therefore determinant yedu inenge iri 0 since singular matrix and since we have singular matrix and so panapa takuti so 3x minus 2 and determinant is equal to 0. How to find x? So collect my like terms. 3x is equal to 2, then divide both sides by 3. So x is equal to 2 over 3. So this is our answer. So this is singular matrix. Right, tiniya to identity matrix. Identity matrix. It is denoted by I. And there you go. So this is our identity matrix. Parents identity matrix. This one. So now we are going to do these questions number 1 up to 6. So I want to show you how to answer examination the matrix and so those are some questions set on a simsec. So let's start. Right, tine number 1 yatida kuita number 1 a iri kuti iyo 3a minus b anditika. So 3 matrix of a ndiani the negative 2 negative 1 and this one, then matrix b and it munyatsozona. Then manapa toti 6 na 2 and minus b ndiani 0 minus 1 na 4 na 3. Right, panapa this is scalar kaino multiply each. So negative 6 upper 18 upper negative 3 upper 6 and minus 0 negative 1 na 4 na 3. So panapa takuti isusu minus 6 minus 0 minus 6 minus 3 minus 1, so minus 3 plus 1 not per minus 2 minus 3 plus 1 not per minus 2. Then 18 minus 4 18 minus 4 it's 14. 6 minus 3 is 3. So this is our answer. Then part B would your b squared. So b squared do ayaka ndizo do matrix iri apa 0 na negative 1 na 4 na 3. then another foot 0, -1 na4 na3 ndizvo. So toda kuita 2 by 2 matrix anotambodzisana pe 2 mabrackets ako ari kuplaza plus saka panapa tiri kuti 0 times 0 row by column, 0 times 0 -1 times 4 -1 times 4, then takuya row by column foot 0 times -1 0 times -1, then -0 times -1 -1 times 3 -1 times 3, then takuenda row by column foot 4 times 0 4 times 0 3 times 4 3 times 4, then 4 times -1 4 times -1 3 times 3 3 times 3. So panapa it's 0 apa -4 apa 0 apa 12 apa 0 apa -3 apa 9 apa -4. So takuti isu 0 plus -4 -4, 0 plus 12 12, 0 plus -3 it's -3, -4 plus 9 it's 5. So this is 2 by 2 matrix. Alright, number 2 you go to your AB item 1 AB. So A in the 2 na 3, A is 2 na 3, then times B 4 -1 5 na 6 and so noya panapo vurachi bracket rako 2 times 4 row by column 2 times 4 2 times 4 plus 3 times 5 and iri side iri ndo iri satakwenda iri 2 times -2 2 times -1 ndizvo plus 3 times 6 3 times 6 and so matrix aya pasi pese painouya iri 2 by 2 matrix is not always you multiply 2 by 2 matrix, so they can give you this format and so you should know. So panapa 8 and 15 -2 na 18 and 8 plus 8 plus 15 23, then -2 plus 18 -2 plus 18 is 16. Yes, okay. Then item 2, find the B negative, find the inverse of B and it. So inverse of B chekutanga tanga tatsvaga determinant B. Determinant B tinoti isusu 4 times 6 4 times 6 minus 5 times -1 5 times -1 and it. So pana tuona 24 minus 5. So pana 24 plus 5 24 plus 5 tuona 29. So tautsaga chi inverse yedu tauti 1 over chi determinant open bracket. So panapa idzochinjana maposition gets. So tauti 6 24, then this one dzochinjana masign, apana negative apana positive, so -5 na 1. So this is inverse. That's what. Right, and if negative, if bracket this one and it -2p na p plus 3 p na -4p and it is singular, find the two possible values of, and tati kana iri singular takuziva determinant yedu ndiani 0 handiri. So first ngatanga tatsvaga determinant yedu handiri. Saka panapa tikuti negative 2 times negative chi ndizo minus p times p plus 3 determinant ke p times handiri. Takuya negative 2 times negative 4 inenge 8p ndizo minus p times p squared, you remove bracket, minus p times 3 minus 3p handiri. So this is our determinant. And so panapa takuti 8p minus 3p, it's 5p minus p squared, but the values of p, so which means we have two values of p handiri. So panapa takuti sources, therefore determinant yedu ndi 0, so takuti 5p minus p squared is equal to 0. So ichakwenda and takuti 5p is equal to p squared ndizo. Oro right, oro tatiti this one chi common factor and p kusara 5 minus p is equal to 0. Saka p is equal to 0 or 5 minus p is equal to 0. So p ndiani 5 ake ichakaenda inovaita 5, then therefore p is equal to 0 or 5. So those are values of p and it. Right, and given that matrix this one 4 4 negative 3 3 2 na x na y is equal to 29 na 9 ndizo. So zvokuti titsvage ichi matrix x and y, how to find x and y. First thing atore this one totsvaga chi inverse. So what is the inverse of this one? So determinant is equal to 4 times 200 minus 3 times negative 3. So panapa tiona 8 plus 3 times negative, tiona 9, negative na negative positive 9. So 8 plus 9 is 17. Then inverse is equal to 1 over this one, and we open a bracket and this will change my position, and then 3 now is will change my sign this. So now tawana inverse yedu takuchiti so how to find x and y is equal to takutora inverse multiply by this one, and 1 over 17 2 3 negative 3 na 4 multiply by 29 na 9 this. So panapa tikuti source wakuya kusa bracket pakatanga multiply this one, and 2 times 29 2 times 29 and plus 3 times 9 3 times 9 this one. Then tapedza row by column, takwenda pasasi row by column, negative 3 times 29 and plus 4 times 9 4 times 9 this one. So panapa x y. Right, tiri papapa tichati 2 times 29 ndiani 2 times 29 to 58, 3 times 9 27, negative 3 times 29 negative 8 7, 4 times 9 36. I'm good. So just plus this one to plus this one. So now to go to x y, don't forget 1 over 17 please 1 over 17 panapa takuti 58 plus 27 58 plus 27 tuona 85, then negative 87 plus 36 negative 87 87 plus 36, we get negative 51. This one. Set out xy, take multiply 1 over 17 times 85, 1 over 17 times negative 51. So x, y, tuanan. Take this 85 divided by 17, we get 5. 51 divided by 17, we get 3. Negative 3. But our question says values of x and y. So x is equal, therefore x is equal to 5 and y is equal to negative 3. So those are our questions. Then. So ndo ma answers edu, ndo ma tsagira on it. Vamwe vanogona multiply this and this, this and this, then ozongo correspond ake mai chete. And given that m each and n each 5, item 1. The matrix wakatopiwa that the matrix m, saka 3m toshandisa this one. 3m is equal to m. 3m plus n is equal to m. And so panapita kuti 3 open bracket m ndiye a b c d plus n ndiye 4 negative 2 3 na 0 is equal to m ndiye a b c d. And tidotsvaga isusu this one. So panapa iskala kai 3a 3c 3b 3d plus 4 negative 2 3 na 0 is equal to a b c d. Saka tenta kuti ichi ne ichi equation 1. 3a plus 4 is equal to a, equation 1. And then ichi ne ichi ne ichi. And so that 3b plus negative, tungoti negative 3 is going to be 2 guy. And then takuya pana c 3c na 3 na c, 3c plus 3 is equal to c 3. Then takuya e 3d plus 0 is equal to d 4. So let's get this one. So 3a minus a is equal to minus 4. So now we want 2a divided by 2 divided by 2. So a Indian negative 2. Then 3b minus b is equal to solve for this one. 3 again dog, no veda 3. So now 2b is equal to 3 divided by 2. So b is equal to 3 over 2. These are jet 3b. So it's just a sort a way doing the negative 2. Then b in the 3 over 2. That is solve it. 3c is up minus c is equal to minus 3. So upon 3c minus 2c minus 3 minus 2 minus 2. So c is equal to 3 over 2 again. Right. So panapa takuti so d ndiye 0. Naona panapa d akaenda ku 0 kana chini d 0. So matrix yedu iri kuti chia. So m matrix is equal to, and it m matrix and this. So a in the negative 2, then b in the 3 over 2, then c in the 3 over 2, then d 0. The matrix would be right. Then n squared it's 4 na negative 2 3 0 na 4 na negative 2 na 3 na 0. So panapa 2 by 2 plus bracket rako bracket plus bracket then bracket plus bracket bracket plus bracket and so panapa 4 times 4 negative 2 times 3 negative 2 times 3 then 4 times 2 negative 2 4 times negative 2 negative 2 times 0 0 then 3 times 4 3 times 4 plus 0 times 3 then 3 times negative 2 then 0 times 0 sapanapa ndakuti 0 0 negative 2 negative 2 3 3 so it's done sapanapa is 16 negative 6 12 0 negative 8 0 0 negative 6 takuya panapa 16 minus 6 16 minus 6 16 minus 6 is 10 apa 12 apa negative 8 apa negative 6 so ndo n squared yoyo. Right, the exercise yakwe ndo exercise yenye find the matrix P such that P bracket 0 matrix here is equal to identity matrix and so 3 marks. Thank you. So my number is 0779795012 or 0717493993. Thank you so much.